Alright, welcome back. For this video, we're going to look at projectile motion. This past week, we looked at 2D motion, or motion happening in 2 dimensions. As a quick reminder, if we have an object moving 10 meters per second in the northeast direction, we should be able to find out how quickly are they moving in the east-west direction and the north-south direction. I can find the horizontal and vertical components of my problem. I know that there's some part of my velocity is moving eastward and some part of my velocity is moving northward. I just don't know how much. So if you remember to last week, we have a quick trick to finding the horizontal and vertical components of our initial velocity. If I want to find the horizontal component, I just multiply the initial velocity by cosine of 70 to find how much is moving eastward. And if I wanted to find the vertical component of my vector, then I just take the original velocity, which is 10 meters per second, and multiply it by the sine of 70. Remember that funny little saying, y sine cos x? So after quickly using your calculator, you can see that my initial velocity in the x direction is 3.4 meters per second. And that my initial velocity in the vertical motion is 9.4 meters per second. This is just a quick reminder that if you're moving in 2 dimensions, you're moving with some velocity in the x dimension, and you're moving with some velocity in the y. And we can see that it's not the same. It would be the same if it was moving at 45 degrees, but it's not. Okay, so last time in class we talked about this dilemma. If you had 2 bullets, and they're both at a point 2 meters above the ground, one bullet is just going to be dropped. The second bullet will be fired from the gun completely horizontally. Which bullet will hit the ground first? So I know what you're thinking. The real ringer here is the bullet that's being fired horizontally. We've got to look at its behavior. So as soon as the bullet is fired from the gun, it leaves the gun, the bullet is now experiencing 2 different types of motion. It'll experience a horizontal motion, and it will also experience a vertical motion. So the big question here is, how much does the horizontal motion affect the vertical motion? The first thing we got to ask ourselves is there a dimension that experiences, I don't know, some sort of acceleration? Yes! When we let objects go in midair, they fall. Things fall naturally. That's because there's a force. We never talked about force before. I know we haven't talked about force yet, but we have been talking about this type of force. Gravity! So gravity is always making objects accelerate. That's why objects accelerate, because there is a force, which is gravity, which points down, which makes objects accelerate downward at 9.8 meters per second squared. So even though an object might be moving in 2 dimensions throughout the air, it might be flying throughout, so the bullet's motion in the vertical dimension will always be accelerating. What about the horizontal motion? So as long as there's no other object or thing that is touching the bullet, like air friction, which we're assuming is not there, the bullet will continue moving with a constant velocity. So it turns out that the bullet will move with a constant speed in the horizontal direction, and the bullet will also experience a constant acceleration in the vertical dimension. So that still doesn't answer the question. How does horizontal motion affect vertical motion? It doesn't. It turns out that the horizontal motion is completely independent of the vertical motion. It doesn't matter how fast the bullet is being fired in the horizontal direction. It could be fired 1,000,000 meters per second. The vertical motion will still accelerate at the same rate. Let's say it again. Horizontal motion is independent of vertical motion. One does not affect the other. The only thing that affects motion is really forces. And the only force present in an object in the middle of the air is gravity. Gravity always points down towards Earth. It does not point right to left. So there's nothing causing this object to accelerate right to left. Which all brings us to what a projectile is. A projectile is any object that's moving in 2 dimensions under the influence of gravity only. It's kind of like free fall, except for this object is moving in 2 dimensions, not just up and down. Remember, free fall does not happen right to left. Free fall only happens downwards. So if you lived on planet Earth long enough to realize how objects move, you should notice that when objects are thrown in 2 dimensions up in the air, they move as a parabola. So if you notice, projectiles produce a parabola shape as they're flying through the air. The reason why we see a parabola is because the horizontal motion is independent of the vertical motion. The bullet moves with a constant velocity in the horizontal motion, meaning the velocity stays constant in the horizontal direction. It doesn't change. That's why the blue arrows are the same length. It always stays that speed throughout the whole trip. The velocity in the vertical direction does change throughout the trip. That's because it's experiencing acceleration because of gravity. So notice that the size of my velocity vector in the vertical motion gets smaller as it gets to the very top. In fact, this one right here, the very top of the parabola, has no vertical velocity. That's because it's 0. We learned about that when we looked at free fall problems. When you throw a ball up into the air, we know at some point it's going to hit 0. The same thing is true only in the vertical motion. All projectiles experience no velocity at the top of its peak. So right here at the peak, it has no vertical velocity. It's not moving up or down. It has a 0 meters per second vertical velocity. So that's why we get a parabola. The x motion stays constant, but the y motion changes due to acceleration, due to gravity. So you can use similar tricks when throwing a ball up to the air as you do with a projectile. Any projectile flying through the air at some point has a vertical velocity of 0. And at that point, the object will have a max vertical displacement. But the horizontal motion will keep going. It doesn't care about the vertical motion because they're independent. So I understand that I might not have said the answer to the bullet versus bullet question yet. Let's actually figure that out. So we have 2 objects moving in 2 dimensions. Let's do what we normally do to figure out this problem. So we got to look at both objects in both dimensions. Let's first look at the shot bullet. So the shot bullet, in the horizontal section, it just has a horizontal velocity of 100 meters per second. The shot bullet also has a vertical motion. What we know about the vertical motion is it's going to experience an acceleration of negative 9.8 meters per second squared. And we know that it's going to fall 2 meters. It's going to have a negative displacement, taking up to be positive. We also know that its initial velocity in the y direction is 0. It's being fired completely horizontally, which means it doesn't have a vertical motion, which means it doesn't have an initial vertical velocity. It only has a horizontal initial velocity. Don't get the 2 mixed up. Okay, that looks pretty good for our shot bullet. I think we have all the stuff that we know. Let's look at the dropped bullet. So the dropped bullet should look very similar to the shot bullet. The only difference is that the dropped bullet doesn't have any horizontal velocity. So if we're going to see which bullet hits the ground first, we have to look at their vertical motion. Both bullets have the same givens and unknowns. We're just looking at the vertical motion, and they have the same acceleration, they have the same displacement, and they have the same initial velocity, which is 0. So we can use the same equation to solve for the time it takes for the bullet to fall. Neither bullet has initial velocity, so we can just get rid of that term. So I just have my displacement is equal to 1/2 AT squared. So when I'm looking for time, I'm going to have this form. That time is the square root of 2 times the displacement, all divided by acceleration. So let's plug in the numbers and see how long it will take either bullet to hit the ground. So if we put in everything correctly, we can see that the time for both bullet is 0.64 seconds. It doesn't matter that the fired bullet had some initial velocity in the x direction. That doesn't affect the vertical motion. So there it is. If you said that both bullets would hit the ground at the same time, go ahead, pat yourself on the back. You're smart. Just for a quick recap. any object that is experiencing projectile motion is going to have two types of motion. It's going to have a vertical motion, which experiences a constant acceleration, and it's going to have a horizontal motion, which experiences constant velocity. So under the horizontal motion, we will always use this type of formula. Always the constant velocity formula. You're never going to have a formula with acceleration in it using for the horizontal motion. And likewise, you're not going to have any constant velocity motion in the vertical motion. So this formula can tell us all we need to know in the horizontal direction, while these three formulas can tell us what's happening in the vertical direction. They do not cross over, meaning we can't use a formula from the vertical side over the horizontal. They don't affect one another. There is one quantity that talks to both sides. Time. Notice that technically time is the one thing that can transfer over from the vertical side over to the horizontal. You just have to make sure you're talking about the right time, which we'll get into later on this week. You know how on our equation sheet we had those pesky little subscript x's on the bottom, and you kept saying, Mr. Shep, what is the subscript x about? And I was like, ignore those, ignore those. Well, we can stop ignoring them. Don't get confused. All it's saying is that you have the same component and the same dimension for each formula. So for instance, when I look at my vertical motion, all of these are y's. It's all in the y motion. I don't have a subscript x with the other subscript y's. I can't have my change in displacement y is equal to my initial velocity x. That doesn't make any sense. You can't mix vertical motion up with horizontal. So the subscript x's just tell us that we're working in one dimension at a time only. And I know that they're x's, and over here I have y's. I don't know why College Board did it that way, they just did. But you should know that the vertical motion accelerates at a constant rate, while the horizontal motion experiences a constant velocity. So that's projectiles for you. Have a good one.